Okay, so last session Priyanka covered very beautifully what is virtualization, and then she spent a lot of time discussing what the virtual machines are, and then she said this is all old technology, new technology is containers, right? So in containers, this session we are going to do hands-on with Docker, so that by the end of this session you guys feel like you are like masters of Docker. Okay, how do you go? Okay, so the agenda: getting your hands dirty with Docker. 3 parts. First thing is understanding. So just some terminology, some basics of Docker, what is the Docker file, what are the commands and so on. And in parallel, we'll also be playing with Docker. So you'll write your own Docker file, you will build it, you will run it, you will do whatever you want with it. And finally, some advanced concepts. I'm calling it advanced, but actually it is sort of, if you have some practical requirements, a real use case, you're going to need all of these concepts, okay? Things like how to copy, how to expose ports and so on. So these are more like practical concepts of Docker that you will need apart from just running Hello World. So these are the 3 things we will be doing in this session. It's going to be very hands-on, so I hope all of you have Docker installed and you will be running the commands in parallel. So I think Priyanka covered some of this terminology, so let me just do that for the sake of completeness. So I will be going with the analogy of source code for you to understand the different concepts in Docker. So the Docker file is basically just a list of instructions, right? It says stuff like run this command, install this thing, move it here, move it to your downloads or something, all those sort of things, right? So these are some commands that you have, set of instructions that like a recipe to follow. And all of this, if you follow, this is like source code, right? Just when source code says do this, do that. So this is the equivalent of source code. But you just don't keep source code running, right? Just like sitting, right? You have to do something with it. So for that, you first compile it. So the equivalent of compile is Docker build. So what do you do when you compile a source code? You get as a.out. So likewise, when you Docker build a Docker file, you will get an image. An image is what happens when you follow these instructions in the Docker file. You will get this frozen state sort of thing of runtime environment that you will get if you follow all of the instructions in this Docker file. And then again, if this is the equivalent of a.out, what do you do to the a.out? You run it. You do /a.out. So the equivalent of running is Docker run, and the running process is now a container. So container is the runtime instance of an image. Fourth is the Docker registry. So again, if we go with the source code analogy, so Docker registry is where you can pull and push images, some sort of a thing where people can push their images if they have made it, if they've built it on their own, and then you can use it just because it's convenient to use someone else's instead of writing your own from scratch, right? So what is the equivalent of this in source code? GitHub. Thank you. So, but Docker registry can, like GitHub, be either public or private. Public means there's examples like Docker Hub, where you can get all sorts of famous images like say Python or anything that you want. And there's also private. For instance, in IBM we have a private registry where we keep all our, it's all very, we can't reveal it outside. So we need those images, we run it in a private registry. And finally, the brains of all of this is this Docker engine, the daemon that Priyanka mentioned. And this Docker engine makes sure that if you run Docker build and stuff, somebody is there to know what to do with it. Docker run, everything it can manage. So a little bit of information for you to understand what is the difference between an image and a container properly. So for this, you will actually need to understand the layers architecture of Docker images. That is a bit advanced for the first slide. So I do have some slides about it in the end. We will cover it if we have time. If we don't have, I will share these slides and you can look at it if you're interested on your own. But without the context of all the layer architecture, 2 things that you have to remember. So like I said, image contains this frozen state that you get when you run all the Docker file instructions. So with this state that you have, a container will take the state and then run something on it, run some process. That is the main thing that you want the container to do. It should run something. So container takes the image and runs a process on top of it. But when you run some process, it will make changes to this image or whatever the file system where it's running on, right? It will make changes, it can add some files, it can remove some files, it can do stuff. So, but this means that the image will get changed, and then if someone uses the image later, then they will get this changed image. So you don't want that to happen. So for that, what happens is what I've written over here, the container takes the image, and on top of that it just slaps a writable layer. And it is writable because all the containers changes will then get propagated to that layer alone. And when you kill the container, you lose that state. So this is just maintaining the state of the container. And this means that first the containers changes don't get written to the image. And secondly, that with the same image, you can run multiple containers at the same time. So this allows sharing between multiple containers. So just like a summary, if you have to take away one thing from the last slide, you have a Docker file, you build it to get the Docker image, and then you run that to get a Docker container. These are the three most important stages in Docker. So don't run this command yet. So this container image you can either build locally, that is this Docker file path that I mentioned, or you can pull from a registry. Somebody else has created the image and you can pull that image from the registry. So you pull it by just using Docker pull, and just a bit on this notation, right? This is the name of the image. Sometimes you can say some, like GitHub, you can have some path / name. Like if you create a, this is because it's very very like an important or a popular image, it's just called Python. If you create your own Python image, it can't be just called Python. So you will say something like Kavya / Python. And then colon is followed by the tag, which is, for instance, you can say then 3.8 when you release a 3.8 image. It just helps keeping track of all of the things. And after you pull, the image is available locally in your system, and then you can just run it. And in fact, they just help you out by saying that you can directly run, and if it's not able to find it locally, it will just pull it anyway. So you don't have to specifically run the pull command. This is what Docker Hub looks like. Can you see anything there? So for instance, you can see a lot of images. I'll just focus here on Grafana. It has 1 billion downloads. It's a very, very popular cloud monitoring thing. So that's why, like, literally everybody who's running something on the cloud will deploy this. So this is why you have a lot of things. Then you have some 10 million downloads and all that. So this is the number of people who have pulled this image. And if you see specifically into this image Docker Hub page, it looks a lot like GitHub's README, right? You just put a README, it says how do you run this particular container, and then you have these tags, and tags will tell you, like, you have 10.1.5 and then you have 10.0.9 Ubuntu, so you can just have a lot of different information also in this tag, so that you can, for all your requirements, you can get a Docker image that matches that requirements. So now let's get to the hands-on part. So we are going to run Nginx container. So Nginx is a server software, and it basically allows you to send HTTP requests to this thing, and it can serve like static web pages if it's located in a particular directory, or if it is an index.html in a directory, it will serve that. But right now, for the first few slides, we are only going to look at Nginx as a container, not as Nginx itself, right? It could be anything. We are going to run Nginx. So now I want you to run Nginx, and this command will automatically pull from the registry also. So you can, it'll take a little while depending on how much bandwidth is available if all of you collectively pull this huge thing, right? Okay, so I'll assume most of you have it running. So, and it probably is occupying one of your terminals, your main terminal. So now you'll need to open another terminal in the same VM or your machine to do the next command, right? So now we'll run Docker PS on the other terminal. So let's just look at the output of Docker PS. If you have run some other terminal, some other container before, right? For instance, when Docker installs it, runs that hello world, so you might find something else also in your output of Docker PS. Let's comment Docker PS 8. Okay, so Docker PS should probably show this running container. So you can see there's a container ID. This is just a random string that it's created for your container. Image. So command, this is actually related to the same process that I was talking about. When an image starts, when a container starts, it takes the image and then runs a command on top of that. So this is that. Created and status, and port, it understands what port this command is running, and finally name. So you all have some weird names for your containers. So basically Docker just assigns a name for your container just to make it easy for you to refer to it later. So any command that you run later on that is related to this container, you can use either this container ID or this name for referring to it. So next, let's do Docker inspect of either your container ID or your name, and it will print a lot of output about your container. So there's a lot of detailed information about the container, useful for debugging. but right now it's just useful for you to see what all Docker does on the inside, right? So if you scroll from bottom to the top, you'll first see a lot of network related settings. For instance, it tells what the IP address of your container is that it had assigned. It knows about the ports that you're running and a lot of all the bridge related networking. So you will see some more details about this in, I think, tomorrow's session or maybe today's session, but you will see a bit more in depth about all of this Docker networking stuff later. Then you will also see some container related configuration. For instance, environment, right? So these are all the environment variables in this image that you can then refer to in the container. This command is again the process that is actually running in the container. Here you can see it's nginx with some additional arguments to it and other stuff and more stuff. So basically, yeah, args is one of the most important things that you can see. And here in state, you can see some more information, right? It says it's running. It has some other stuff like running, paused, restarting or what, and things like that. So that is enough for enough details about your container, I think. Now you can call yourself DevOps engineers. You've run a container. Okay, so this is another useful command called docker stats. And if you run that, it will give you statistics about your running containers. For instance, how much CPU is it using? Right now it's not doing anything, so it's using 0 CPU, but it is using some memory and so on. And again, when you learn about C groups, you will see that it can actually limit how much memory your container is using, and it can even like end it if you're using too much memory, right? So now we are done with this container. Let's kill this container. So just do docker rm of the name or the CID. And you should get an error saying that your container is running, so you're not allowed to kill it. And it is very helpful. It says you can either stop it or you can force remove it. Force remove sounds nasty, so let's just stop it. Okay, so docker stop, or you can just use the docker stop command. Docker stop of your container ID or name. And it will probably say container stopped or something. And now you can do inspect again on your container. Amongst all that information, there was this thing that was talking about state, right? And here you can see that it's what has changed. The status is now exited, and running is false. I think you just said running was true before. Running is false. Now that your your container is stopped, you can kill it. So now you can do docker rm of your container again, container/id, and try to inspect it now that you have killed it. And now that it's killed, it does not retain any information about your container. So now it says no such object of your container's name. So even when it was stopped, it had some information, but now that it's killed, it doesn't have any information about your container. Okay, so we saw when the container was running, we saw that it had a status of running, and now when we have stopped it, we see the status exited. So what is this status, right? So again, container is an instance of an image where it is running a process. So status is the state of that process that it was running. So there are around 6 or 7 status that a container can be in. First is created. So created is a container that is not started yet. So you use the docker create command to create it. So what happens when you do docker create is that that writable layer that I mentioned, right? Only that thing gets created, but the process doesn't start yet. So once you have created a container using docker create, you then use docker start to then start the container. But it's not the only way of starting a container. And next is running. That is when you do docker run, you have a normal running container, right? The process is running, everything is normal, and it uses as much CPU and memory as the process needs. So third is exited, and this is when we did docker rm, or if the process terminates on its own. Maybe it was just a process that had like sleep 5 or something, right? It could terminate on its own, and when it terminates, it goes into exited state. The container still exists in that exited state. So the process could end naturally, it could end manually when we do docker stop, or it could end in a bad state because of some error like code panic or something, but it's still counted as exited. The fourth is restarting. So when we saw, if you take a naturally terminating job, right, when it ends, the container just goes to exited. But there is an option this is the dash restart option, which allows the container to start as soon as it ends. For instance, the sleep 5 sort of command where it just finishes and then restarts again. And in that in the middle time, it's called restart. It's in the restarting mode. And fifth is paused. So if you do Docker pause of a container, it actually goes into the suspended mode. And in this state, the process is suspended, CPU is released, memory is still consumed, and it is just held in that mode, and then you can unpause it to resume it later. It's just a fun fact. People use this, for instance, for checkpointing and then restarting elsewhere. So you just pause it, tar the container, do it elsewhere, or even migrating, right? Put it elsewhere and then unpause it, and then it just starts as though nothing happened, right? And finally is removing, where when you do Docker RM and if you catch it somewhere in the middle, it is in the process of being removed. I think there's one where it's some sort of a zombie state, but you don't have to care about that. And if you are interested in knowing all about the CPU and memory usage, you can run docker stats command every time it's in one of these modes and see how much it was using. For instance, you could pause, see docker stats, and then unpause and see the docker stats again. Okay, so now that we have run a container by using someone else's image, let us build our own image and run our own container, right? So like I said, two options, you can either pull or build. When do we use what? So when you want to just play around with something, you can just use someone's created image, right? Python, you can just use Python image. Or sometimes, if you're running in the cloud, for instance, you have created your own image, but to access it from a Kubernetes cluster, say, you have to push it to a registry and then you have to pull from that registry elsewhere. So it could be your own image that you're actually pushing and pulling. And when do we build? Again, for creating any application that runs on the cloud, if it has to run as a container, you have to create your own Docker file and then build it. And otherwise, if you just want to like build something for your project or something and you want to share it amongst other team members or something, you will need to create this environment using a Docker file. Some example Docker files, these are from our own things that we have used, right? You might need to spin up a Docker file for a lot of things. So first is networking experiments. So you can see so there's the base image, and we used memcached base image, and then we installed stressng so that we can stress test memcached inside the container and see how memcached behaves, right? What is the throughput, what is the latency, and all that we can see. Second is K8s network simulator that Chandran and Priyanka did last year at ComSets, and it is a large Docker file, but in that they installed Go, so that there's a Docker file with Go installed for you guys to try out. And in that, for instance, you just wget downloads something. Run is a command that you use for running stuff inside your Docker file. Wget just gets the Go binary, you untar it into user local, and then you set that path, right? Env, for instance, sets the environment variable in your Docker file. So all of these are just like examples of what a real life Docker file will look like and what are the commands you'll need to do. And this is actually for 23rd or 24th session on application layer networking, where we're going to do gRPC. But I didn't want all of you to install gRPC on your own machines. It's a lot of pain. So I just created a Docker file which has gRPC installed. So you just run the pip install command to install gRPC. All of that just fits beautifully in a Docker file. For instance, I also have some exercises for you to do. So I will copy that into something in the Docker file, into some location in the container. So, and for that I use the cp command. So these are some of the example commands that you can see that a Docker file will consist. So this is just a list of all the commands, a proper summary from the last one, right? So you can either specify an existing image or scratch, and this says that I want all of the things from that image to come to my this thing. So if you want to build a Python based application, you can just say from Python, and anything that you don't have to install Python, right? You can get away from the hassle of installing that. And then is copy, and this copies from the host to the Docker file. So this is into the container. That is always needed if you have something of your own that you want to put into the container, right? Run, as you saw, most of the commands are run, where you can do anything of like wget or install or like apt-get update, apt-get install, right? All of those things you run using the run command. Then there are some additional helpful stuff like workdir. Workdir sets the working directory so that the subsequent commands will then run with this as the working directory. Environment sets some environment variables so that then you can use it in later commands, or it gets installed in that Docker file, Docker container. And finally, this is a very important thing, which is entry point / command. There's two commands, entry point or CMD, and both of them are used to do this, which is this is the command that the container runs when at the moment it gets started. So this is the main thing which decides what your container is going to do. For instance, we saw nginx with some arguments was the command that they used to run the nginx container. And the it looks like this. You have say nginx here, and then you give the params through separated by commas, right, in quotes. Instead of just putting the command in a single line, you put it in that format. So it's easier for it to parse it. Okay, I think this is a summary of, you see from Python, and you see the environment variable so that I can use that in the later commands. You see run, you see copy, and you see entry point. So these are the different commands that you run to build a Docker file, to create a Docker file. Sorry? Are you talking about? Oh no, I'm setting the environment variable grpc to 1.1.15, and then later on I can use that environment variable, or you can use it in the container. Any process in the container will then see this as the environment variable. Okay, so that was all knowledge. So now let's create our own Docker image. Oh, okay. Entry point is the command you give so that when the container starts, it runs that process. Okay, we are going to create our own Docker image, and it's going to be based, we are going to create a simple customized server. So three things you need to do when you're going to write your own Docker image, right? What is the base image, the from command? What changes do we want to add? This is all the run commands. And what is the command to execute, which is the entry point or GMD. So what is the base image we want to use? We're going to make a server. And I just made you run something. So what's the base image you're going to run? Nginx, yeah. So what, let's start with Nginx. You all need to open a file called Dockerfile, right? And you can put from Nginx and close that for a while, because we're going to do this customization of the Nginx server, right? So Nginx basically serves any index.html file on a port. So for that, the customization we're going to do is that we're going to create our own index.html, put that into the Docker file, and make Nginx use that. Okay, so I want you guys to just create an index.html with this as the body. Just create a folder for this hands-on exercise, and then just put this index.html, just let it lie over there, and put this body, put this HTML file in that index.html. Okay, so we're done with first one. For second, just create a file called Dockerfile, and the first line you'll put is from Nginx. So if you're done with the first, the second command, by default, if there is an index.html sitting in this location, user share nginx HTML, it will serve it automatically on the / endpoint of the server. So we're going to use that to our advantage by copying this our created index.html into this location in the image. The thing is, this file is local, and you want it in this path inside the image, right? So we are going to use the copy command that we saw. The copy, you can use copy, you can use cp also, which will copy from path in the host to destination in the container. So you can just use it as it is, right? Copy, source, destination. Okay, so the third point is that you will copy your local index.html into the image at this path, and finally you need a command to run, right? What should the containers, what is the process the container should start? So one thing you can do is just look at the previous Nginx image we ran, the output of inspect, docker inspect of that container ID, to see what was the command they ran, and then we can copy and paste the exact same command in our CMD as well, in that same format, right? Of square bracket, quotes, comma, and then end square bracket. If you are feeling very brave and this thing, you can just run simply Nginx and see what happens to the image, and then try to debug it. But for that, you will have to go to the build. You need to go to the build stage, but you need to do multiple runs to debug the issue if you just run Nginx instead of the actual output command. It's there in the PDF. So this is the sample Docker file in case you guys are want to see a template, right? So this is a sample Docker files, but now you need to run the commands that we need to do. Okay, I'll come back to the Dockerfile thing if needed, but if you guys have created something and you want to just test it out, right, to see if it's working or not. So this is the command to build your Docker image from the file. Docker build -t is tag, and you say you can name it whatever you want here, and dot says that the Docker file will exist in this directory. So just do Docker build -t, anything you want, dot. Okay, so you should have a Docker file at this point, which has from Nginx this copy command, and additionally this command, which is wrong, should be -g. It just so happens that because we're using the base image as Nginx, if you don't specify a command, it will use whatever command Nginx had. So actually you didn't need to do the command, but I just wanted you guys to get a hands-on feeling of how to run the command. So if you didn't put the command also, your container would have run perfectly fine. Okay, just a quick show of hands. How many of you are able to write your Docker file? How many of you are able to build it as well? You're able to see all the output that it was showing, right? So -t is tag. -t is tag. You specify a name for your image using this, including the version you can specify in this. So -t, you can give anything you want here. You can put your name /Nginx, or you can put your name anything here. It will build the image with this name. Slash is the namespacing that Docker uses so that you don't get confused. It follows this parsing this strategy for, you can give anything you want here. It will not take the name from the container, it will take whatever you give here. If you give something wrong here, it will confuse you, but you should usually give something that is relevant to the container that you're building, the image that you're building.
There's one command here which I copied over there. And there's this other command that seems to call it recursively.
Okay, this is the container config, and it's the config it came with. So yeah, so the way there's a little bit of difference between entry point and command. I didn't get into specifics. Basically, command is the arguments to a command, that sort of a thing. So if you use entry point and command together, command gives the arguments to the entry point itself. So now, whatever we gave as command in your Docker file went as arguments to this guy, which said bin sh and now run this thing inside, right? So it became like recursive that way. So either way it ends up running it, but you can use entry point also if you want for neatness, or you can do nothing also, wherein it just runs whatever Nginx came with, which is there in the config automatically. Okay, so I hope you're able to build your image and then you're able to run your own image, right? And it should look exactly the same as the normal Nginx, so you can't actually see any difference. So now how will we see our changes in action? So for which we'll see one of the advanced topics, which is communication with the container. So the problem is Nginx is running inside the container, but from outside you're not able to reach it. And the reason is because of the isolation that containers provided. Is part and parcel of containers is network isolation, and because of that, by default you're not able to reach the container if they are exposing on some port. So for this you need to be able to ensure that from outside, that is from your machine or host, you want to be able to talk inside the container or the other way around. So for this there are two options. The first option is port forwarding, and there's another option which we might use in one of our later hands-on sessions. So in port forwarding, what we do is that we assign a port on the host machine and make it refer to a port on the container. So if Nginx is running inside the container and wants to expose on port 80 and you want to reach it from outside, you will take a port on the host machine, say something like 8000, and forward from host 8000 to containers 80. So you could have multiple containers running like this, and they could have different ports that they are exposing inside the container, and to access it you take the host machine and then you expose some of the ports from the host machine to the container machine, and from outside you can give the host machine's IP and then do 8080 or whatever you want, and you'll be able to reach inside as though it is the Apache container or the MySQL container. So we are going to make our server accessible so that you can actually see the Nginx server running. This is the command for port forwarding. Here you can use your Nginx image, or if you had trouble building, you can use the normal Nginx image also over here if you want. You won't be able to see your index.html. You'll be able to see the default index.html that Nginx provides. So this is how you do port forwarding. Here I'm just giving a name for the container. That's not necessary, but you can use it to refer. You can use your own name to refer to it, right? And -p 8080 is the host port, and 80 is the container port. You can give any port you want on the host side. The container port has to be 80 so that you can refer to it. So if you run your container this way, and actually if you have been running containers with this custom names, you'll be getting a lot of error conflicts. So you will have to RM and kill the containers with the same name before you start another container with the same name. Or you can just leave it and it will keep creating different containers with different names. But basically you can use -p 8080:80 to refer to port 80 inside the container from your host machine. And now if you're running Linux and this is running on your machine, you can do localhost. If you are on a VM, you have to use a VM's IP over here, :8080 from a browser to be able to see your index.html being served. We can stop the old container, the one that was running without port forwarding, because it's not accessible now. Stop it, kill it, and then start another one if you want the same name. Stop, docker stop for killing docker rm. It will not delete the image, it will delete the containers. The image is built with your name /nginx. That image is still running, is still existing on your system, even if the container goes. And for this, the thing is that on your host machine, that port that you have chosen, right, like 8080, it should be free. Nothing, no other process should be exposing on that port. So if you get a conflict issue, then you will need to change the host machine port. So were you able to run it either your Nginx or the default Nginx with this port forwarding option? Can I get a show of hands if you're able to do the docker run command with the port forwarding? And were you able to see your index.html being served? Okay, so this we will not do, we'll just see how it works, right? So how would push work? So, stop. Okay, so let me go to the next one. These are all, I think I'll just be covering theory from now on. So how do you push, right? So first you need a container registry to exist. You will need login to that registry. So if it's a public registry like Docker Hub, or even GitHub has a GitHub container registry, GHCR. So for all of these, they will give you instructions on how to log in to this registry. One important step is that you will have to retag your image. So basically you will follow the registry's practice of tagging, and you'll have to tag your image with that. So Docker tag just says that if this exists, rename it as this. So both of them will exist from now on as images in your system. And you have to tag it with the registry name over here, and then only you can push it. So there's a quirk that these registries have. So just a summary of all the Docker commands that we ran, right? We had a Docker file. We were able to build it and create an image. Then you run an image to get a container. And container has a lot of things like stop, start, etc., which are all container related operations. The image can be tag command creates another image. You can push it to a registry. You can pull from a registry. Also, Docker has this command of being able to convert an image to a tar file. So you can just like move it around without having a registry. So the save and load commands are used to convert it to tar. So these are the primary Docker commands that some of which we saw and you will probably use. Okay, so the remaining ones I'll probably just cover it as theory. So when you ran the Nginx container, right, you would have seen that it occupied your terminal because it was running in the foreground. You can also run the container as a daemon or in the background. And for that you use the -d flag. So -d doesn't stand for daemon, it actually stands for detach. So that means that it will run in the background, which means you gain control of the terminal again, and that means that it could just be running something in the background and you don't have to care about its logs actively, right? But if you run something like that, and now you want to execute something in that running Docker container, so you use the exec command. So exec basically you specify the name of the container, and then you can specify a command, and with this you will be able to run any command that you want in a container that is already running. And then exec also has this additional flag of -it, which is interactive, which means that you can get a terminal in the container by running docker exec it of the container, and then you specify the command, which is just bash. And when you do -d, these containers will keep piling up because they'll be in the background. So you will have to once in a while do docker ps to understand, see how many docker containers you have running, and then do stop and rm to remove them all. And one more advanced concept that you will need if you use containers is file sharing. So basically, so this custom Docker image we built, right? So what we did was we wanted to change a simple index.html and put it inside the container. And for this, we had to take the base Nginx image and then create a new Docker image for that. We don't need to rebuild the image every time a file changes. File change should be easier to do, right? So for this, what we need is a command to send files into the container and take files from outside the container. Especially if the container is running a process which is creating some file, and then you want that file away from the container, right? So for this, you have two options. Docker gives two options. One is simply copying files, and second is this technique called bind mounting. So just those two options are a little bit different. So if we take this as a host file system and this is the container. So let's see the first one, which is copying a file. So you just copy this file or a folder, right, into the container. You just say like index.html be copied, but except this is not in the image, this is in the container. We will say I want you to copy this particular folder into the container at this location. And this is a one-time copy, which means that if you create a folder in the container, if you make any changes to the folder in the container, it will not get reflected back on your host file system. That is what copy provides. But what bind mount does is sort of reflecting the changes. Basically, it just mounts this host folder that you're talking about inside the container, and they're both referring to the same folder. So now, if you create any changes, if you make any changes on the host file system, it will reflect inside the container. And if you make any changes inside the container, it will reflect in the host file system. So you can have therefore interactively making changes to a file and having it reflect in the container or host file system as you want. So you have two options: copy something from outside into inside one time, and bind mount to ensure that one folder is shared between both the container and your host file system always, so that you can add on either side or delete on either side, and changes are reflected. And for both of these, you have separate commands. So docker cp is the command that allows you to copy from anywhere to anywhere. Actually, it's from the host to the container and also from the container back to the host. So actually, what we could have done instead of building our own image was take the normal Nginx and run it so that you have a normal Nginx running, and then do docker copy of this index.html that you just created. And for destination, you actually give the container name : as the destination path, and then put it inside user share Nginx HTML. And after this, if you run it, you'll be able to see the changes. So instead of building your own image, you can just use the normal image, done a one-time copy, and it will be accessible inside the Nginx server, which means it will now be able to serve that new file. And the second option is bind mount, where we can create a folder because it's easier to mount a folder to a folder. So we're saying this folder is going to correspond to the HTML folder. Now, if we make any changes inside the target folder, so even if we didn't do the copy before, right, just create a folder, run the Nginx container with bind mount of target to the special Nginx folder, user share Nginx HTML. We say whatever happens in target will happen in this HTML folder instead. And now when you copy index.html to this target, it will get reflected in the container. And when you and if you make any changes also, it will immediately get reflected in the container. And then because it's on port 8080, you can just see the changes happen instantly. So you have two options. For instead of creating an image, you could have actually just done these two options to be able to see your created index.html inside a container. Yeah, I can end it. So yeah, okay. In summary, because it took very long. So in summary, we saw how to pull Docker images. We saw how to create our own Docker file. What are the commands from run and cmd command to actually run a process inside a container, and run a process inside run stuff inside an image. And when we saw that a container is an image plus a process that is running, and you guys were able to write your own Docker file, build it, and run it. And finally, we saw port forwarding for being able to see any server that is exposing something on a port inside the container. How do you see it from outside, right? We saw port forwarding, and finally we saw how to copy files into and outside Docker container.